sense. You got to understand it, though. But once you understand it, it's common sense. So f is a continuous function. No holes, gaps, or jumps, right? What is the least number of times that f of x can make 2? Well, the answer is 2. Here's why. I plotted the points. Now, you don't have to plot the points. You can tell just by looking at the table, but I like visual, so we're going to go with visual. So here's all my points. So it's continuous. It starts at 0, -1, and then it goes up and then down. And the question is, how many times does f of x equal 2? In other words, the y value equal 2, and the answer is at least twice. Now, you can tell that from the table, because look, if you're going from -1 to 3, you must have got to 2 at some point, right? And then if you're going from 5 to 0, you must have gotten to 2 again, right? So there has to be at least 2 times you cross the y value of 2. You guys good? All right. So this is like the easiest way I could present to you this overcomplicated theorem known as the intermediate value theorem. Okay? The intermediate value theorem is basically just a theorem that says if you start at point A and you end at point B, somewhere along the way, you must have crossed that point there in the middle. Does that make sense? That's it. So don't overcomplicate it in your mind, but I'm about ready to overcomplicate it on the board here, because that's what we do as math teachers. We take the simple and we make it ridiculously hard. So here we go. Intermediate value theorem. Ready? Here we go. Hypothesis. This means that's the conditions that have to be met for this to work. If f of x is continuous, can't have any holes, gaps, or jumps, because if it does, that's not true anymore. Our theorem won't work. Second, f of a and f of b have to be different. So in other words, one of them has to be lower than the other. They have to be at different heights. Okay? Because the next thing is that we're going to pick some random y value between there. Okay? So if you have a continuous function where the endpoints are not at the same height, you could pick some random y value between there. Then it has to be the case that there is at least one x value, which I'm going to call c, between a and b. And I've got 3 there that I've listed. There's got to be at least one value of x where, when you plug it in, you get that y value. So don't you guys agree that for this value of c, it's k? And this one too? And this one. But that's terribly overcomplicating it, right? Let me re-simplify it for you. If I go from here to here, then somewhere along the way, I had to cross that green line. That's all it's saying. So let's look at it again. If it's continuous and you're going from one point to another, and there's somewhere in between there, right? Then there has to be some point where the x value in between there will give you that particular y value. It has to cross that level. This is what's known as an existence theorem. It doesn't tell you what the c values are. It just tells you they have to be there. It's kind of like whenever, you know, a mom comes home and she sees the cookie jar has been raided. She knows a child has been in her kitchen. Right? She doesn't know which child it was, but she knows somebody was there. All right, so I don't know. That's what happens when you make up analogies on the spot. They don't come out so great. Okay, so here we go. This thing is called the intermediate value theorem, abbreviated IVT. Use the IVT to explain why there has to be at least one value c. Remember, that's an x value, but we're calling it c, a specific x value, such that f of c equals 5. So what this is saying is there has to be some x value that I could plug in so that I get 5 as an answer. Okay? So here we go. I've got a function, right? And I've got an interval. Both of these are x values. We'll call this one a, we'll call this one b. Okay? So I'm wondering if I should kind of just go with a common sense approach first, and then we'll go back and do the complicated, right? So I've got a function, right? 4x minus 3. That means the y-intercept, don't write this, just watch. Negative 3, rise 4, run 1. There's my line, right? I'm going from 0 to 3 on the x-axis, from here to here. So in other words, I'm going from this point to this point. What we're going to prove then is that somewhere between here and here, there's some x value where whenever I pick that x value, whatever it is, it will be here on the line, and the y value for that x value will be 5. Okay? That's what I'm going to prove. Which means this one must be what? Something greater than 5, right? And we can figure that out. So here's what we're going to do. We're going to find out what these 2 points are first, right? We're going to make sure all the criteria is met. It's continuous. The endpoints aren't the same, right? The 5 is in fact between those two y values. And if all those things are met, then that means there must be some x value where if you plug it in, you get 5. That's basically it. Okay? Way overcomplicating a very simple idea, but that's how it works. Okay. And you'll probably see 1 or 2 questions like this on your AP exam, so it's worth looking at. You'll see a lot of it in our review materials. All right, so the first thing you want to do is you want to look at this statement, and you want to identify what A is, what B is, and what K is. A and B are your starting point and ending point on the x-axis. Okay, so go ahead and label those if you haven't done so already. K is what I'm going to say is the y value that you're trying to reach. So in this case, we want to prove that there is a somewhere, there's a k there, right? Of 5. Now let's see if it's continuous. Is this function continuous on that interval that we're looking at? Okay, so yes, this is continuous on this interval because this is always continuous. So check, check, right? Find f of a, and by the way, I'm going to give you some homework problems where it's going to say, why can't we use the intermediate value theorem to prove that that point must exist? And it might be because it's not continuous. Let me draw my picture again. If this thing wasn't continuous, and I was going from here to here, and let's say 5 was here, if this thing wasn't continuous, is it possible that the hole was right where the 5 would have been? That is possible if you had a certain function, right? And in that case, you can't say it exists anymore, so it's got to be continuous. So you're going to have a homework question. We have to find out why doesn't the IVT apply here? And it might be because it's not continuous. All right. Now we got to find f of a and f of b. How do I do that? Plug them in. So what's f of a? F of a is f of 0, right? And f of 0 is 4 times 0 minus 3, which is negative 3. Now let's do f of b, which is f of 3, and that's 4 times 3 minus 3, which is 9. So here's my f of a and f of b. Check. So now I know what it's going to. It's going from, my y values are going from negative 3 to 9. Is 5 somewhere in there? There you go. All right. Verify that k is between f of a and f of b. We just said it. I'm going to write it like this. F of a, f of b, and k. I want to prove that this is true. So what was f of a? Negative 3. What was f of b? 9. And what was k? 5. Is this true?
Yes.
Check. Okay, we're good. So, found a, b, and k. We know it's continuous. There's no holes, gaps, or jumps. We know the y values go from negative 3 to 9, and therefore the k value that we want is in fact between there. Now we write our answer. How do we know that point exists? I'm going to show you guys how you have to write this. This is FRQ stuff again, okay? Multiple choice questions for these was like the table I showed you before. How many times would it equal to? It's that simple. But free response stuff, you have to write your answer in a certain way. This is a great thing, a great thing to put on a flashcard, which, by the way, I've already printed them for you. They're on Google Classroom. You just have to print them out and memorize them. I put that statement on a piece of paper, and you just got to quiz yourself once in a while on how to say it, because I know at the end of the year you're going to be like, oh yeah, it's that thing where you say, if this, then that, and but I have no idea how to say it. And that's because you didn't use your flashcards. But if you use flashcards, you're right. All right? So, here it is. Here's your statement. Since f of x is continuous and goes from, what did it go from? F of x, not x. -3 to 9 on the interval. Those are x values. So since the function is continuous and goes from -3 to 9 on the interval from 0 to 3, there has to be some value c on that interval such that f of c equals what number? 5. There you go. And by the way, this is all just stuff to help you guys. All this here is to kind of help you work through the nitty-gritties of the problem, but they never will tell you to do that. They're just going to say prove it, and this is your answer. So these are all just helpful hints on how to do this. This is your question, this is your answer, and that's it. This is just steps to help you kind of understand the requirements and what each piece is, where the 9 and the 3 come from, etc. Okay, but they're not going to tell you to do all these things. That's just me helping you out. This is the question you'll see. That's the answer you'll write. So let's do another one here. This is a guided practice, which means I'm going to let you guys do a lot of the work, but we're still going to do it together. I'll pause. Why don't you guys do me a favor when we do part A? I want you guys to identify A, B, and K. Go for it. What is A, B, and K? Is okay, so we got to understand the language here. What's the 0 of a function, you guys?
What's the 0 of a function?
You don't know what a 0 of a function is?
Like, what do you like?
That's actually a vocabulary word of like 0. It's a synonym for the root or the x-intercept. So what they're saying here is that prove that there has to be a root, and this is really what the IVT has used a lot for in mathematics, is it's to prove that there has to be some point where the line crosses the x-axis at that point. So a 0 is where it crosses the x-axis. So let's say that's my 0. I don't know what the 0 is. We'll call that c. But what would f of c be equal to? 0, because it's on the x-axis. So if it says use the IVT to explain why the function has a 0, that means your y value, your k value is 0, because that's the point where it's touching the x-axis. But anyway, so that's step 1. Part B, go ahead. Check to see if it's continuous on the interval. Go ahead. All right, so I'm going to ask Nicholas Miller. Where is this function not continuous? Breaking my heart, Miller. Breaking my heart. Go ahead, Pearl. You're looking in the right spot, but I'm not hearing the right answer. I want to hear an x value, not. You're looking in the right thing, but you're not saying the right answer.
So would it be the top part?
No. Now you're looking in the wrong spot.
So I was right there.
Yeah, but I need the right answer. So let me ask Graydon, where is this function not continuous at?
Good question.
All right. Amanda? No. All right. I'll throw out there volunteer. Anybody? Neha? Why is it not continuous at -1? Makes the bottom equal 0. Naughty, naughty calculus students. Naughty. All right. So If the function's not continuous at -1, that's the only place it's not continuous. Let me ask the question more specifically then. Let me ask of Caitlin Smith. So Caitlin, is my function continuous on the interval that we're looking at? No, it actually is. Let me tell you why. Where is it discontinuous at? Is -1 on that interval from 0 to 1? So my function's continuous from 0 to 1. Now, if I wanted you guys to use the IVT like on this interval, for instance, you would stop and you say, oh, we can't use the IVT there. There's a hole somewhere in this function, and I can't be sure that k value is going to exist. But in this case, since we're going from 0 to 1 and the discontinuity is at -1, we're going to say, yay, we can do the IVT. All right, let's continue. Let's go ahead, and I want you guys to find f of a and f of b. You're not allowed to get this one wrong. If you get it wrong, I have to actually... All right, I'm asking James Pinedo. James Pinedo, what's f of a and f of b?
I got -3 and then 3/2.
I have to punch you halfway.
Wait, what did you get for the second
Isn't it? Let's
Three
see.
over two.
1,
It
5.
is 3/2.
Oh, Mr. Bailey, now we gotta punch you.
Yeah, now we have to punch.
Yeah, it is 2.
Isn't this
Plus.
6 minus 3? Oh.
Wow.
Give Jimmy his put.
Go give him a little punch.
Right here. Right here.
Really tough.
Good. A half punch. Very nice. Very nice. All right.
I was really thinking about
Dude, I thought you were
that.
going to. I was like,
Then I have to fill out paperwork. Let's not go there. All right. Let's go ahead and do part D. Now, I'm going to just ask you why. Verify that K is between f of A and f of B. So I'm going to ask Pearl.
Yeah, wait. -3. Or
Is-
which is less than, not less than, which is less than.
-3 what?
-3 is less than 0, which is less than 2.
Good. Here's my K. There's my f of A and f of B. It's between there. Okay, that's all that matters. So my function's going from -3 to 3/2, which is about 1.5. And somewhere along the way, we've got to cross a y value of 0. That's all that's saying. So that means we're good now. So we've done everything then. We know it's continuous. We know it's going from -3 to 3/2. We want to know, does it cross 0? We know it does. So if it crosses 0, there must be some x value that gives me y equals 0, right? And that's our statement. So I want you guys to go ahead and complete that statement. I'll give you, this is important. Make sure you guys know how to do this. What goes here, sir? Here? Here? 1? You're right. Brackets are good. And last one. 0. Now, memorizing things doesn't work very good. I didn't memorize this statement, okay? But I can say this statement to you without looking at it just because it makes sense. So it should, I hope you guys don't just try to memorize. I hope you actually try to help this make sense. So first of all, let's understand the basic idea. Right, here's the basic idea. I'm going from here to here. Therefore, at some point along the way, I got to cross that point, right? Now, I got to make sure we meet our criteria, though. So that part I do have to memorize. Okay, so since my function is continuous, and it's going from this y value to this y value, there must be some point along the way where I could plug an x value and it'll give me that y value. And that's all this is saying. Since f of x is continuous and goes from -3 to 3/2 on the interval from 0 to 1, there has to be some c value, that's an x value, such that when you plug it in, you get that y value. So make it make sense, and then you don't have to memorize it, okay? All that matters is, but these blanks we filled in, you have to state that. You have to state what the y values are, what the interval is, and what point has to exist. Yeah? It's not. But it's discontinuous where? At -1, right? It's -1 on this interval. No. So we can say since it's continuous on the interval. That's why it's important to say that interval there. Now in the last problem, I didn't have to say that technically. You could have just said, well, this is a linear function. It's continuous everywhere. So of course that point has to exist, right? All right, so one more for you to let you do completely on your own. You do number 1, and if you get time, that's extra credit at the bottom there. Do it on a separate sheet of paper. You don't have to do it tonight. You could, or today. You could do it tonight and turn it in tomorrow. But if you do turn it in tomorrow, just make sure it's on a separate sheet from your homework, because when I grade homework, I don't really look at every problem carefully. Extra credit I do. So make sure on a separate sheet. So I want you to do number 1 right now in class. Number 2 is extra credit. The extra credit is telling me why the IBT doesn't work for these 2 problems. Now, you have to go back to that sheet that talks about the hypothesis. It has to be continuous. F of A cannot equal F of B, and K has to be between F of A and F of B. If any one of those things don't happen, then you can't use the IBT to promise that there's going to be a point there. So that's that. I'll put the answer for this one up in a little bit. You guys know? Yeah. If they gave you a letter and you were the wrong one, yeah, you lose points.
What if you put F of X instead of T?
That's bad. Yeah, they would take points off.